Hi, welcome back. Today we are doing an integration problem from my past paper exam. I think it's an Indian past paper exam, so you can pause the video, go ahead and give it a try, or just watch me do it. Alright, so the integral of sine of natural log of x plus cosine of the natural log of x. How do we begin? I think I'm going to change the variable from x to something else like u. So I'll let u to be the natural log of x. If I put exponents on both sides, I'll have exponent u equals x. And then could just take derivatives because I want to substitute for dx in terms of u as well as x. So exponent u du equals dx. Okay, so where there is dx, I'm going to put this. So let me rewrite the integral now. That's integral of sine of u plus cosine of u, and instead of dx, should just put brackets here and say exponent u times du, which I could of course write as sine. I prefer to write exponent u first, sine u, okay, du plus the integral of exponent u cos u du, and I think this looks nicer. So let's evaluate this and then bring back the two integrals together. As you can see, each of these integrals is a combination of an exponential function and a trig function. The same applies to this, so we've got to use integration by parts. And for this special case, the integral will reappear when you have an exponential function and a trig function, so that's something to expect. I'll leave a link to some of my videos where I talk about integration by parts. I think more specifically the DI method or the tabular method, the table method, which is actually a shorthand way of doing integration by parts. Okay, so let's go ahead and do that. So I'm going to begin with this alone, the integral of exponent u sine u or du. So using the table method, I choose one function that I'll differentiate and then one function that I'll integrate. So let's differentiate exponent u and let's integrate sine u. That's nice. So plus, minus, plus, that's how the method works. So if I differentiate exponent u, I get that. If I integrate sine u, I get negative cosine u. Okay, if I differentiate exponent u, still, if I integrate negative cos u, that's negative sine u. Okay, and at this point you can see exponent u, sine u reappears, so we stop at that point. No more. Okay, so let's write out this integral. The integral of exponent u sine u du equals, so we multiply diagonally, this multiplied by this, exponent u times negative cos u, that's negative exponent u cosine of u. Okay, let's come to the next one. Negative times a negative, that's going to be a plus exponent u sine u. Okay, what else do we have here? This multiplied by this, the integral itself, when we multiply on the same row, so that's minus the integral of exponent u sine u du. As you can see, if I carry this integral over to the right hand side, it's going to add, so there will be two integrals. So finally, I've just concluded that the integral of eu sine u is actually going to be a half. I should just pull out exponent u out, so I'll have a half. That's going to be negative cosine u plus sine u. Okay, plus a constant, of course, I'll just put that at the end. So let me write that answer here. I'll just come back to it. So that's a half exponent of negative u, negative cos, so that's cos u, exponent u, so negative cos u here plus sine u Alright, so let me clear this up and then I solve the second integral and we'll put them together. Alright, for the second part of the integral, exponent u cos u du, I'll use the same technique. So I have di, so I'll differentiate exponent u and I'll integrate cos u. So if I differentiate exponent u, I get the same thing. If I integrate cos u, I get sine u. Okay, if I differentiate exponent u, I get exponent u. If I integrate sine u, I get negative cosine u. So this integral, the integral of exponent u cos u du is actually going to be, okay, multiply this by this, diagonal exponent u sine u. Alright, the minus and the minus, that's a plus, okay. So plus exponent u cos u, alright, and then multiply this with this, that's the integral itself, minus, remember we stop when this integral reappears, so this is minus and positive, that's a minus integral of exponent u cos u du. Still, if I carry this integral over to the right hand side, there will be two integrals, so I can just conclude that this integral is a half exponent u. You can try to simplify this, come up with this sine u plus cosine of u plus a constant, which I'll just indicate at the last part. So let's put these together. I'll just write this here. This is a half exponent u, so I have sine u plus cos u, alright? Okay, so I just won't repeat this, but I'll just bring that up here. So if I add these two integrals together, I think you can see that a half exponent u is common in both. Then we have negative cosine of u plus sine u plus sine u plus cosine of u. So the cosine cancels and we'll have a half exponent of u. Then we have sine u plus sine u, which is 2 sine u. At this point I think I can add a constant because of putting the integral together to conclude. So this 2 cancels with this 2 and I have exponent of u sine u plus a constant. But remember, u is just a variable that we changed. In the beginning we had x, so I've got to put back x, so that's exponent of natural log of x, because u is natural log of x from here, sine of the natural log of x plus another constant. Then exponent of natural log of x is as good as x. This is sine of the natural log of x plus a constant. Alright, thanks for watching this video. Tell me in the comments if you were able to solve this alone, and I'll see you in my next video. If you find this helpful, give me a thumbs up, subscribe to the channel for more content like this. I'll see you in my next video. Bye.